In this tutorial, we'll be seeing that how Scipy works with statistics and random numbers. The modules scipy.stats contain statistical tools and probabilistic descriptions of random processes. Now, random number generators for various processes can be found in numpy.random, but we'll be using scipy.stats so as to see that how this functionality works. So first, let us import the necessary library. So from we'll have to do from scipy import stats, import numpy as np, and from matplotlib import pyplot as pl3. Right, so this is all that we'll be importing. Now let us first have a samples array, which is nothing but np.random.normal, right? And normally it has been distributed, and let's give the size as 1000, and let's print samples. Yeah, so this is our samples array. After that, we need to have, let us first discuss about histogram and probability density function, right? So given a process of random, given observations of random process, their histogram is the exterior, their histogram is the estimator of the random processes of probability density function, right? So we'll be computing that. So if we have to use histograms, we'll need bins. So let's keep our bins as np dot arrange, uh, and let us keep it as -4 to 5, right? And let's print our bins. So yeah, this is how our bins look like. Now we have to get the histogram. So let us name histogram is equal to np dot histogram. Yeah, I guess we got it. And first of all, we need the samples. Then we put the samples as per our bins, and we'll have to keep bins is equal to bins, and our density is equal to 2, right? And the first part. So here, let's try to print it, right? So this is how our histogram looks like. Now our bins will be equal to 0.5 into, now bins of 1, the very first row, the first row in all the columns, and we'll be adding it with bins of all the rows and the last column, right? And let's get the bins. Yeah, so yes, so here we have the array now. Now what do we have to do is that we had imported our stats. Now we'll be using a normal distribution object, right? So how we'll be doing is, let me just write and explain that after. So we'll have our probability density function, which is pdf is equal to stats dot norm dot pdf, because we have to see the distribution of the bins, right? So that is how we do. And after that, now let us first understand the norm thing. So scipy.stats.norm is a distribution object. Now each distribution in scipy.stats is represented as object. Here it's the normal distribution, and it comes with a PDF or a CDF. So a PDF that we have used here is the probability density function, right? Now let us just plot it and see. So we'll be doing plt dot plot of bins and histogram, and after that let's just see this, right? And let's do it as plt dot plot of bins comma pdf, right? So this looks like this. So both of them are quite similar, right? So this is what we had to see, that we had been given the observations of random process. Their histogram is an estimator of the random process, which is PDF. So that is what we did here. Now, if we know that a random process belongs to a given family of random processes, such as normal processes, we can do a maximum likelihood fit of the observations to estimate the parameters of the underlying distribution, right? So now we fit a process, a normal process, to on the observed data. So let us just give it as a location and standard deviation is equal to stats dot norm, and we'll be fitting samples here, right? And let's print our and our std. Sorry, yeah, right. So let's just see the documentation for the same. Here we go. So MLE stands for maximum likelihood estimator. So it returns MLEs for shape, location, scale, and scale parameters from the data, right? So the parameters that it takes is the data, and yeah, it returns multiple tuples, so tuples of floats, right? And this function uses explicit formulas for the maximum likelihood optimization. And this is the example that they have been given over here. Next, we'll be saying about mean, median, and percentage. Now, the mean is the estimator of the center of the distribution, which we normally do it as np.mean. Median is another estimator of the center. It is the value with half of the observations below and half of observations above. So that can be simply done by np.median. Now, unlike the mean, the median is not sensitive to the tails of the distribution. It is robust. And if you ever came to the term digital image processing, median is used, and it is very robust because for the salt and pepper noise. So the median is also the 50% percentile, and let us see how that we can do. How can we compute that? So it is just as stats dot score at percentile, and we'll be using samples and 50th. So that will be a median, right? So if I just do np dot median of that, we'll be using samples. So median is by default 58th percentile. So yeah, this is the answer that it gives us to. Now, any type of percentile, you can find it over here. So what if I want to find the 75th percentile? So yep, here you go. And what if we have to find the 90th percentile? So this is how it finds the percentile based on the data that we have given over here. So what basically does is that it divides the data, and after dividing the data, it gives us the mean or the median of that percentile, right? So this is what our stats percentile does. Now there are several statistical tests that can be done. Before that, now always remember that percentile is an estimator of cumulative distribution function, and norm uses both PDF and CDF. PDF is probability density function, and CDF is cumulative distributive function. Now, coming back to statistical tests, now a statistical test is a decision indicator. For instance, if we have two sets of observations that we assume as generated from Gaussian processes, we can use t-test to decide whether the means of two tests of observations are significantly different or what. So let us just take two different tests. So first test, let it be A, and we do it as np.random.normal distribution we are taken again, and from 0 to 1 will take, and let's keep the size as 100. And our second is mp.random.normal, and that is take it from 1 to 1, and size is equal to 10, right? So let us print A first. So our A looks somewhat like this, and thereafter we have our B. So here we go. This is what our B looks like. Now we want to do the t test. So that is stats dot t test, right? And we'll be using this one, and we'll be doing on both A and B. So let's just first see the documentation of t-test. So this is the documentation, and calculate the t-test for the means of two independent samples of scores. So these are two independent samples that we have taken, and they have identical average expected values. This test assumes that the population have identical variances by default. So these are A and B parameters that we have given, axis, then these are several other parameters, and it returns a statistic float or array, right? And p-value float or array. So this is what our statistics value looks like, and this is what our p-value looks like as it has returned. So the result output is composed of, first you can see t statistic value. It is a number, the sign which is proportional to the difference between the two random processes, which are A and B, and the magnitude is related to the significance of the difference. The second output that we are getting is a p-value. It is the probability of both process being identical, that how much identical they are. If it is close to 1, two processes are nearly almost certainly identical. Closer to 0 means more likely that the process have different means. So this is more near to 0, and this means that they have different means, right? So this is what our stats module looks like. Now, there are several other modules under Scipy that you can look out for, such as, first of all, we have scipy.integrate, and this is used for integration functions. The function integrates. Thereafter, we have scipy.optimize, and this is for the optimization and fitting of the curves, right? And there is one another interesting package under Scipy, which is Fftpack, and this module computes a fast Fourier transforms and offers utilities to handle them. After that, we have scipy dot image, and that is something that we'll be learning in our next tutorial. Thank you.